Hi everyone. Today I'm going to introduce you sequences and series. We will learn how to write the end term of a sequence and how to find the partial sum of a sequence. Basically, a sequence is a pattern of terms defined by the term number. For example, here we have a sequence 1, 3, 5, 7, 9, and so on. So this will continue. So the first term is 1, second term is 3, third term is 5. So based on the term number, we have a pattern which is actually repeating for each term here. So here I can find the first term as A1. So when I'm going to put a variable here as n, which is the counter of these terms or the term number here. So it's 1, n is 1, 2, 3, 4, 5, and so on. So when n is 1, A1 is 1. Excuse me. So A1 is 1. When n is 2, A2 is equal to 2. When n is 3, we have A3 as the third term, which is equal to 5, and so on. Now here we want to find the nth term of this sequence. To find the nth term of the sequence, we basically need to find a general rule or general formula for that to find the nth term of this sequence. So I need to find a relation between the number of the term and the terms that I see here. So if I look at these terms, when n is 1, A1 is 1, n is 2, A2 is 3, n is 3, A3 is 5. So by just having a closer look at these numbers, I can see that if I multiply n each time by 2, I will get, for example, for the first one, I'll get 2. And then if I subtract 1 from that, I will get 2n minus 1, which is 1 here. So this will be 2 times 1 minus 1 equal to 1. For the second term, again, 2 times the number of the term, which is 2, minus 1 will be 3. The next term, 2 times 3 minus 1 will be 6 minus 1, which is 5. So I can find the general rule of the nth term by finding the relation between the n number of the term and the terms here. So the general rule of this sequence is 2n minus 1. Now let's look at the next example. 1 over 2, 1 over 4, 1 over 8, 1 over 16. So when n is 1, A1 is equal to 1 over 2. When n is 2, A2 is equal to 1 over 4. And so and so. So if I look at all these terms, I see that each denominator here can be written as a power of 2. For example, the first one is 2 to the power of 1. The second one, the denominator is 2 to the power of 2. The third one, when n equal to 2, we have 1 over 8, and that's 2 to the power of 3. So I can write the general rule as an equal to 1 over 2 to the power of n. So this will be the nth term of this sequence. Let's look at the next problems. In these problems, we need to find the first 4 terms and the 100th term of the sequence. So I know that each term is related to the number of that term. So if I want to find the first term, that's when n equal to 1. So A1 will be equal to 3 times 1 squared minus 4, which will be 3 times 1 minus 4 is negative 1. That's the first term. For the second term, n will be equal to 2. So it will be a2 equal to 3 times 2 squared minus 4. 4 times 3 is 12 minus 4 will be 8. N equal to 3. A3 will be equal to 3 times 3 squared minus 4, which will be 3 times 3, 9, times 3 is 27, minus 4 will be 23. And for n equal to 4, it will be a4 equal to 3 times 4 squared minus 4, which is equal to 44. And in order to find the 100th term, I'm just going to replace 100 for n. And 100 will be 3 times 100 squared minus 4, which will be equal to 29916. Now let's find the next one. For the next sequence, to find a1, n is equal to 1. So a1 will be negative 1 to the power of 1, which will be negative 1. Second term, negative 1 to the power of 2, which will be positive 1. Third term, a3 equal to negative 1 to the power of 3, which is negative 1 again. N equal to 4, a to 4 equal to negative 1 to the power of 4, which will be positive 1. So if we continue this sequence for 100, we will have negative 1 to the power of 100. And because 100 is a positive number, negative 1 to a 100 is an even number, negative 1 to the power of an even number will be equal to positive 1. The next one, an equal to negative 1 to the power of n plus 1. N is equal to 1, so a1 will be negative 1 to the power of 1 plus 1, and that's negative 1 to the power of 2. Notice that for all these negative ones, I'm going to put them in parentheses, because if I don't put that in parentheses, like this for example, this is basically equal to negative 1 to the power of 2. Especially if you put this in your calculator, this will give you negative 1. But if you put it in parentheses, that will be equal to negative 1 to the power of 2, and it will be positive 1. So make sure if you're using your calculator, put in parentheses. Even in just writing them, it's better if you write in parentheses. Anyway, negative 1 to the power of 2 will be positive 1. Then n equal to 2, a2 will be negative 1 to the power of 2 plus 1, which is negative 1 to the power of 3, and it's negative 1. N equal to 3, a3 will be negative 1 to the power of 4, positive 1. And 4, a4 to the equal to negative 1 to the power of 5, negative 1. And for n equal to 100, we will have 100 equal to negative 1 to the power of 101, and this is an odd number, so the answer will be an odd number. It will be negative 1. Now let's see what is a recursive sequence. a sequence when you get the next term by doing an operation on the previous term. This is called a recursive term. Basically, to find any term in a recursive term, you need to know the previous term. So in recursive sequences, mostly or always, the first term is given to you. So if I want to find A2 in this term, I already have A1, so I'm going to find A2. To find A2, it will be equal to A n minus 1, means 2 minus 1 plus 3. So that will be A1 plus 3. And we already have the value of A1, which is 1. So I replace that here. It will be 1 plus 3 equal to 4. To find A3, I need A3 minus 1. Plus 3, which will be A2 plus 3. And A2 is what we just got here. It's equal to 4. So 4 plus 3 is equal to 7. To find A4, I need A4 minus 1 plus 3, which will be A3 plus 3. And A3 is what we just got here. It's 7 plus 3 equal to 10. So for each term, I need to have the previous term. For example, if I want to find A10, I need to have A9 plus 3 and add it to 3, and then I get A9. So that's called a recursive sequence. Now let's talk about partial sums. Partial sum is actually sum of part of a sequence. For example, if I have a sequence like A1, A2, A3, A4, so and so to AN, and so, and I ask you to find the sum of the first 4 terms. So you're going to add A1 plus 2A, A1 plus A2 plus A3 plus A4. That's called the partial sum, or sum of the first 4 terms of this sequence. Or I might ask you to find sum of the first 10 terms, or sum of the first 100 terms of this sequence. That is called partial sum. So here in this example, we have a sequence which the general rule of the nth term can be found by an equal to 2n plus 3. And we want to find S1, S2, and S3. S1, S2, and S3 are actually partial sums. S1 is sum of the first term, S2 is sum of the first 2 terms, S3 is sum of the first 3 terms of this sequence. So let's first of all find the terms of this sequence. A1 will be equal to 2 times 1 plus 3, which will be 5. A2 will be 2 times 2 plus 3, which will be 4 plus 3 is 7. A3 will be 2 times 2, I'm sorry, let me fix this. A3 is 2 times 3 plus 3, which will be 6 plus 3 is 9. So I have A1, A2, and A3. Now to find S1, I just need to add the first term, which is just 5. So just 5. S2, so S1 was A1. S2 is A1 plus A2. So it will be 5 plus 7, which is 12. S3 will be A1 plus A2 plus A3. So it will be 5 plus 7 plus 9. It will be equal to 12 plus 9 is 21. So if I ask you to find S10 of this sequence, you need to find all the terms from A1 to A10 and then add them all up, and that will be equal to S10. Now let's talk about series and summation notation. A series is sum of the various numbers of elements of a sequence. What is the difference between series and sequence? A sequence is listing the terms. For example, A1, A2, A3, A4, and so. So I'm just listing the terms one by one. But series is adding up all these terms together. So this will be A1 plus A2 plus A3 and so on. So based on the number of the n, actually, like if we're asking to find the first n term, so I'm going to find A1 to AN and add them all together. So this is the difference between series and sequences. Series, which are sum of various numbers of elements of a sequence, can be written by summation notation. This is the notation that we use for series, actually. We call this notation as, this symbol is called sigma. So this symbol is called sigma, and AI here is the sequence term. So if you consider A1, A2, A3, and so on, so AI is one of the terms of this sequence, where I is the counter, the variable that is counting the terms, or we can also call it as number of the term. Number of terms. N, which you see it here, is the ending number or ending term. One that you see it here is actually the starting term. So I can read this notation as the sigma of AI. I starts from 1 to n, and that's actually equal to, so when I say sigma of AI, I is equal to 1 to n, that's actually A1 plus A2 plus A3 plus AN. So I'm going to set each term as AI, and then I will be changed as 1 to n. So each time I'm going to add 1 to the value of I and write them all here. And then I'm going to add them all together. So the starting term here is 1 and the ending term is n. Let me give you another example. Let's say I have sigma of 2 AI, and I is from 3 to 5. So in this example, this sigma notation will be equal to 2A. So the starting I is 3, so A3. The next term will be 2A. I'm going to add 1 to 3, will be 4, so it will be A4. Then 2A, the next term will be A5, because I'm adding 1 to the value of this I, so it will be 5. And I'm going to stop here because that's the end of my terms. So this will be the series that can be shown using this sigma notation. Let's do these examples here. Write a series represented by summation notation, then evaluate the sum. So in this case, we have sigma of I squared plus 2. And I starts from 3 to 5. So I'm going to start with the first term. When I is equal to 1, the first term will be, or basically, excuse me, I should be started with 3. I'm not going to start with 1 because it's written here I starts from 3. So when I is equal to 3, the first term will be 3 squared plus 2. Then I is equal to 4. So the next term will be 4 squared plus 2. Then I is equal to 5. The next term will be 5 squared plus 2. And I'm going to stop here because the last term is when I is equal to 5. So it will be equal to 3 squared, 9 plus 2 is 11, plus 16 plus 2, 18, plus 25 plus 2, 27, and it's equal to 56. So that's the final value of this summation. For the next one, there's a typo here. Let's call this as 2i. So instead of having 2x, let's write 2i. So I starts from 4. So the first term is 4. So when I is 4, I have 2 times 4. Then I is equal to 5. So 2 times 5. Then I equal to 6. 2 times 6. I equal to 7. I 8. 2 times 8. I equal to 9. 2 times 9. I equal to 10. 2 times 10. And then I'm going to add them all together. So to find the final value, you need to find each of these, like 8, 10, 12, 14, 16, 18, and 20, and then add them all together and find the value of that. Last problem of this lesson is writing this series in a sigma notation form. To find sigma notation of a series, we need to find a sequence formula first, then find the starting, and then find the ending term. So first of all, let's find the sequence formula. We need to find a relation between number of the term and the term that we see. If I look closer at these terms that we see here, is 3 to the 3, 3 to the 4, 3 to the 5. So I see that a counter is here and it's being added each time. So I can count this as my I value. So I first time is 3, then I is equal to 4, it's added 1, and then it's added 1 more, and it's equal to 5, and so on, so until we reach to the 20. So that is the power that I see here can be counted as my counter or the term number, and the term itself is 3 to the power of this number. So I can write my sigma notation in this form. Each term is 3 to the power of I, and that I starts from 3 because the first term is 3 and ends at 20. So this will be the sigma notation of this series. I've written another example here for you. So let me erase this and do it again for you. For this series that you see here, I have 1 over 4, 1 over 8, 1 over 16, 32, and so on. So if I look closer at these terms, I notice that each denominator is actually a power of 2. So I can write it as 1 over 2 to the power of 2. 1 over 2 to the 3, 1 over 2 to the 4, 1 over 2 to the 5. And the last term is 2 to the 10. So I see that there is a constant term here as 1 over 2 and something which is changing each time. And each time is added 1. So I can count that like the power, count it as my counter, and then the term itself, the constant term, will be each term of my sequence. So I can write it in this form. Sigma, let me write it better. Sigma of 1 over 2 to the power of I. Because this I is the power which is changing. So you choose the value which is changing as the I, which is changing as the number of the term. So I starts from 2 because the first term is 2 and ends at 10. So this will be the sigma notation of this series. So this was today's lesson. Hopefully it was helpful for you. Start working on your homework and practice more to learn better. Have a great day.